Okay, so let's unravel a really strange but very real statistical mystery. It's a puzzle that honestly perfectly shows one of the biggest mistakes our brains make when we try to figure out the world around us.
So, let me ask you a question. Does eating ice cream cause people to drown? I know, it sounds completely ridiculous. But believe it or not, the statistics tell a very, very strange story. Here's a fact. Statisticians have noticed this over and over again. As ice cream sales shoot up, the tragic number of drownings also increases. The two trains move together, almost like they're holding hands. So what on earth is going on here? To solve this mystery, we really need to get our heads around the massive difference between two key ideas: correlation and causation. They sound kind of similar, but trust me, they are worlds apart. The difference is actually pretty simple when you break it down. Correlation just means two things happen to move together. Causation, though, means one thing directly makes the other thing happen. One is just a connection, the other is a direct trigger. So a correlation is just a relationship. When one thing changes, the other one tends to change right along with it. It tells you that two things are connected, but, and this is the key part, it absolutely does not tell you why. Causation, on the other hand, well, that's the smoking gun. It means that event A is directly responsible for event B happening. You take away A, and poof, B doesn't happen. It's a really powerful and direct link. All right, so with those definitions in our back pocket, I think we're ready to crack the case of the killer ice cream. Let's finally figure out what's really happening. Now, if we only looked at the correlation, our brain might immediately jump to this conclusion. More ice cream sales lead directly to more drownings. This is the trap. I mean, it seems to fit the data, but it just doesn't make any logical sense, does it? And here's the solution. It's so simple once you see it. There's a hidden factor at play: hot weather. Right? When it's hot, what do people do? They buy more ice cream. And more people go swimming, which unfortunately leads to more chances for drownings. The ice cream isn't the cause at all. The weather is. This hidden factor actually has a name. It's called a confounding variable. Sometimes you'll hear it called a lurking variable. It's like the secret puppet master pulling the strings on both trends, making it look like they're connected to each other, when really they're just both connected to it. Let's look at another quick example to nail this down. Say a study finds that students with expensive sneakers tend to get better grades. So do the shoes have some kind of magical brain-boosting power? Of course not. The confounding variable here is probably something like family income. Wealthier families can afford both fancy shoes and things like private tutors. And this same type of thinking error doesn't just happen in big studies. It creeps into our personal lives all the time, especially when we start dealing with stuff like luck and superstition. Come on, we've all done this, right? We find some object or some ritual that happened right before a success, and we immediately want to give it all the credit. It feels like this powerful, undeniable connection. But let's just stop and ask the hard question. Did the socks really cause the A? Or, was it maybe the hours you spent studying, paying attention in class, and actually understanding the material? The timing is just a coincidence. It's not the cause. This specific mistake is so common, it actually has a formal name: the post hoc fallacy. It's Latin for after this, therefore because of this. It's the simple but really flawed assumption that if one thing follows another, the first thing must have caused it. And the reason we fall for this so easily is because our brains are basically built for it. We are wired to find patterns, to seek explanations for everything. So when two things happen in a sequence, our brain practically screams connection, even when there's no logical reason for one. So now that we know about all these pitfalls, how do we avoid them? How do we move beyond just seeing a connection and actually find the true cause of something? Well, the answer is to start thinking a little bit more like a scientist. Seriously, if you remember just one thing from all of this, make it this: correlation does not equal causation. Just burn it into your brain. Every time you see two things that seem linked, train yourself to stop and ask, wait a minute, could there be something else going on here? Is there a hidden factor at play? You see, scientists have a whole toolkit for this. They run controlled experiments where they change just one tiny thing at a time. They look for a plausible mechanism, like is there a logical way A could actually cause B? They work really hard to rule out all those pesky confounding variables. And finally, they try to replicate their findings to make sure it wasn't all just a fluke. So I'll leave you with a final thought to test out your new skills. You've definitely heard someone say this. Every single time I wash my car, it rains the next day. So is washing the car causing the rain? Or is there maybe another, more logical explanation at work? What's the real story there?